Hello and welcome to Science Cafe. I see a lot of familiar faces. Let me ask my usual first question. Who has never been to a Science Cafe before? Anybody? Oh, a few people. Oh, okay. All right, I'll give the quick intro then while one of our panelists finishes eating. My name is Dave Brooks. I write the Granite Geek column for the Concord Monitor, and I started being involved with Science Cafe 8.5 years ago when a couple of science fans, Dan Marchek down in Brookline and Sarah Eck out in Lebanon, Hanover area, were basically starting it and wanted some help. And I said, sure, this is a great idea. It'll last 6 months and it'll fizzle out. And as I said, it's been 8.5 years. Can you hear me okay? This sounds good? Okay, good. Oh, excellent. Meet every month. We started up here, went down to Nashua. I came to the Concord Monitor. I worked for the Nashua Telegraph for many years. I came to the Concord Monitor. I started up here, but they're still doing it in Nashua. There's a separate one down there. And if you are not on our mailing list, sciencecafenh.org is the place to go. You can put your email address into it, and then we'll let you know in advance of everyone. So, tip well. Guess I should get my notes better together. Anyway, all right. So the way this works is this. I will not introduce the panelists because I used to and it was really boring. So what I will do instead is ask our three panelists to explain. He's not? No? Well, oh. Never mind. So he did say the third one. Oh, I thought that was, oh. Oh, Frank. Oh, right. He did say the traffic was late. Yep. You're right. I asked you to come, and you said you couldn't make it. That was it.
I said,
that's right.
hire that guy.
That's why. It's, what the heck. Anyway, all right. Our two and eventually third panelist will show up. So basically what I do is I ask them to tell you why you should pay any attention to what they have to say, and then I will ask them the first question. And after that, it's up to you. We have a slightly smaller crowd than usual, so you all have to step up and ask questions and think of interesting things to ask about, so it'll keep going. Just a reminder, we do not have a Science Cafe in December because of Christmas, obviously, and then we will start back up again in January with a topic. I don't know what the topic's going to be yet, so we'll see. And Nashua also does not have a Science Cafe in December. They tried last year, and they found that trying to have a Science Cafe near Christmas doesn't really work. So they will go down. I think that is it for the moment. This is your microphone. And so go ahead. Tell us why we should pay any attention to what you have to say.
You should pay attention to what I have to say because I'm working on a CLT building in Portsmouth, New Hampshire right now, or Newington right outside. I'm still learning about the process. I've been through the design process on it. They plan to start construction on the actual CLT sometime in December, which is very exciting. I am an architect, and I work at SGA in Boston.
And your name is?
My name is Matt Formicola.
Wow, you're efficient. All right.
All right, I'm Eric Kingsley. I'm a partner in the firm Innovative Natural Resource Solutions based here in New Hampshire. I am the main office in that I am in Portland, Maine. Yeah, I don't know what you mean by that either. So I work on the resource side. I worry about forestry, forest industry. My firm works with landowners, loggers, foresters, sawmills, others to find efficient, new, economic uses for wood. CLT, which stands for cross-laminated timber, and I see we have a show and tell, so you all get a great chance to see what that is an emerging technology. I'm actually working with a project in Maine looking to build a CLT mill, and cross-laminated timber and other forms of mass timber are an existing but very much emerging, growing technology. This is, it's not common anywhere. It is accepted in parts of Europe It is quickly growing in the Pacific Northwest, centered around the backup Portland, which we keep in Oregon. Just in case we have a problem with our Portland. But there's enormous opportunity. Cross-laminated timber and other forms of mass timber can be used to make mid-rise. You can never use it for high-rise, or at least as currently contemplated, you can't use it for high-rise. But for mid-rise, sort of up to about 14 stories under the existing code, from what I understand, up to 9 stories of construction. I think 9 stories covers almost everything in New England, not in Boston. I'm sure we can find a couple buildings, but basically New England, when we build, quote, tall buildings, we build mid-rise. So everything from, some of the taller buildings we find in Manchester up through a new market basket at Exit 17, for example, or strip malls could be built of CLT. My new friend Matt is working on a project on the former Pease Air Force Base, which now is Pease Development Authority, on a
Trade port or something like
trade
that.
port, 3 or 4 stories.
3 stories.
3 stories. So there's,
We'll talk about this.
there's fantastic opportunity. My friend Frank will be showing up soon. He's with New England Forestry Foundation. He's wicked smart.
But wicked late. He's not smart enough to avoid traffic, however. All right. So my first question is, so tell us what CLT, what mass timber, what engineered wood is I like that phrase, engineered wood. It sounds so science fiction-y. So tell us what it is and give us a quick history if you can. Is this how new it is and as much as you know? So you can start with the show and tell.
All right, please do. So this is a sample right here of a 5-ply CLT slab. These are called slabs, and they're used in construction for floors or walls. Basically, the way this is constructed is, and come up and take a look if you want after, is it's very similar to plywood. You have the wood running in different directions. So, yeah, turn it this way in section. You can see, I got to stand up here. So you can see that the wood is running in this direction, in this line right here, and then this direction in this wood. And it glues together, and by having the cross laminated, makes it a very strong, resilient member. What else can I say about it? It's got great fire.
What's the size these show up at the site at?
So these can be up to 8 by, I want to say, 8 by 14 or 8 by 15, so 8 feet by 15 feet long. Let me take that back. They might be 25 feet. The only thing that's limiting them is how long the tractor trailer is that's going to go on. So on our building, they worked within our bays, which were about 25 feet. So ours are going to be 8 feet wide by 25 feet long. So the beauty of this is that it's a renewable product. You can harvest the forest, and you can use trees within 2 to 3 years to put this together. These are also finger jointed, so it doesn't need to be a tall tree. It's a great product also because it's lighter than steel. It has a less of a carbon footprint than steel. It takes a lot less.
We'll get into the carbon footprint later.
Yeah, a lot less effort to build this. And I think.
Let me ask you, stop and ask. So let's start with this. So you're saying 8 feet by 25 feet. So this sheet, this thick, 8 feet deep.
8 feet wide. It's like
No.
Well,
Is this for a wall or a floor? Or
either way. So we're using this as a floor slab. So now it's a floor. So we're using it as a floor slab, and basically.
I thought it was going to be really hard to be an architect.
So it's basically a floor right now, and that will be 8 by 25 because these will sit on our beams, and our beam bays are 25 feet. So basically, it sits halfway on the beam.
Right.
Really similar to conventional home construction that you do when you put your plywood down for the floor. All you're doing is using something thicker and requires, a crane to put it in place.
Right. And 25 feet, that limitation is just a function of what they can build and.
I think it's shipping, really.
it's shipping.
It's really just shipping on a truck. Yeah.
So in theory, it could be As long as you want, I mean.
Possibly.
yeah,
I don't know how much sense it would make, but yeah.
Yeah, okay. All right. So, and so is this all that, mass timber is, or are there other things that go into sort of the lump phrase of mass timber? Engineered lumber, and I mean, there's...
Well, yeah, I mean, this particular building, take this anytime you want. This particular building, all right, I know. This particular building that we're doing in Newington is two types of wood, or two types of engineered projects. It's glulam, which we're all familiar with glulam. So we have glulam beams.
Actually, let's talk about glulam.
Okay.
What do you mean by glulam?
So it's very similar to this. It's several smaller members glued together into structural shapes, and they can be used as columns or they can be used as beams. And so we're using those as our, structural frame of the building, and then we're using this as our floors. So, that's another. There's a million. There's the, if you tell a couple of ones.
So certainly cross-laminated timber is the sort of new exciting thing. Laminated veneer lumber and glulam have existed for decades. There are other ways to do cross-laminated timber. This is CLT, cross-laminated timber, and the laminate refers to the gluing process. There is dowel laminated timber that instead of glue uses a dowel, so there's no glues involved, and there's nail laminated timber. Those seem to be trying to compete with CLT without having any significant advantage. I'm sure if someone here is building dowel laminated timber, they'll talk about the glues and everything. But basically, there's a number of ways to attach these together. But really, this is the leading technology. This is what we're seeing. There's a few plants in Canada. There's plants in Montana and Oregon. There's a plant under development in the southeast that's truly under development, and then there's a plant I'm working on that is under, quote, development. That is, it's not yet announced, it's not yet ready to go, but certainly, efforts to move forward. This is effectively 2x4s or 2x lumber, just like we could drive down to Lowe's or Home Depot, by the mall, and buy. So you're using structural lumber, and as Matt talked about, every other layer is facing the opposite direction. So you have a vertical layer giving you vertical strength, followed by a horizontal layer giving you what they refer to as torsional strength, which as a non-engineer, I have no idea what that means. Back to the vertical strength, torsional strength, vertical strength. This is structural lumber in this region in New England and Quebec, where this particular piece is made, and where the panels for the project in Newington are going to come from. This is spruce fir. So this is a forest type we find north of the Notches in New Hampshire, through the northeast kingdom of Vermont, and into really the entire northern half of Maine. New Hampshire in Milan has Milan lumber. We have one meaningful large spruce fir mill. It's certainly, this type of product could be made with New Hampshire and New England lumber. Importantly, as the code currently stands, it can't be made with trees we can drive 20 minutes around here and find. So it's not made with white pine, it's not made with hemlock, it's not made with maple or oak. It's made with structural lumber, just like I'm going to assume exists behind this wallboard and exists on the other side of that. It's that sort of lumber. There are a number of researchers out working on what other species, like we find in southern New Hampshire and southern New England, what other species can be used, because obviously there's so many layers that you develop strength that way. But as it exists right now, this is another use for structural lumber, 2x4, 2x.
All right, I have lots of other questions, but let's go to the audience, and we need questions from you folks. Let me start way in the back. Way in the back. My lovely and talented assistant, Mr. Forrester.
Hi. I'm wondering whether milling the manufactured engineered wood, whether the mills are given specifications for the building, or do they simply manufacture wood and then you cut it up?
So I'll start, and then Matt will describe in some detail. The mills basically form a large panel. In this case, 8 by 15, 8 by 25.
Yeah.
Right. Make a bunch of 8 by 25 panels. However, no one, if we look at that wall and we take a 25-foot section, you see that there's some windows. If we look over here, there's a door. I'm going to assume that there's electric running through there. If we had a second story, there'd be plumbing and all sorts of other things. One of the great advantages is that all of that work is done off-site at the mill. So after they make the panel, it sits waiting for someone to order it. My friend Matt calls them up, sends them a file. I assume it's done electronically. Yep. And they put in whatever holes, runs, whatever else need to occur. Matt will probably talk about this at some length, but one of the enormous advantages is, given that really in America, labor's constrained right now. There aren't enough people to do all the jobs. That is true everywhere, and that is true in construction. And one thing you've done is move the factory site from the building, where it's buildings, I view them as very inefficient factories. And you've moved that up to a more efficient spot where it can be done with CNC routers and machinery and all of that. Now that I've answered the question for Matt, well,
that's fine.
You go ahead.
Okay.
Keep going.
That's a great question, and the long and short is, there are no real, they make this product, just like Home Depot. You go buy your plywood, you go buy it, yes. But what's nice about this is, as Eric was saying, is that it's manufactured. So you can't see this as far away, but if you wanted to pass it over there, you can see that in the ceiling there's ductwork in the ceiling. And our client did not want the ductwork to be below. So just to give you a little background on this building, they wanted the kind of, industrial type of feel, or, an old factory type of feel. So they wanted to express that with the wood. That's another reason to use the CLT. It looks beautiful. In this particular type of construction, it's a type 5B, if you care. But you can have concealed spaces, so you're going to see the ceilings. So we had to use our virtual design to cut all the holes and let the manufacturer know where they were going. So there's a little extra process here, but the beauty of it is, they send us a 3D model, we get to look at it, we get to see where the holes are, and when we go to the site, we expect it to be exactly like that. The other nice thing about that is, and I was doing a little extra research today, is because they manufacture this building, like Eric was saying, not on the site. When you do it on the site, things are like, they're pretty good, they're straight, there's some gaps. Because they manufacture this with CNC machinery, they can get everything tighter together, and it's a better fit, and it's more efficient energy-wise, too, because you don't have gaps in the building. So that's a long answer, sorry.
We have 2 hours.
Yeah.
we have 2 hours.
All right, excellent. Our third panelist has shown up, not to miss it. So you want to tell us who you are and why we should pay any attention to you?
I'm Frank Lowenstein. I'm the Chief Conservation Officer for New England Forestry Foundation. New England Forestry Foundation, how many of you here in the room know it? Like about a third. So we're a 75-year-old conservation organization. We've conserved over 1 million acres of forest land in New England. and including a bunch here in New Hampshire. And we promote we promote improvements in forest management, and we promote policies that we think will support forest landowners. And we think that CLT and building bigger buildings with wood is a good thing for the forest, is a good thing for the forest landowners, and is a good thing for the climate. And I'm happy to talk about why we think this could be a key part of solving climate change when anybody wants to hear about it. I guess the other reason you should listen to me, and my apologies to everyone in the room, is because I fought my way through something that probably you all have to deal with on a regular basis, which would be the Everett Turnpike and I-93 at night. All those folks coming home from Massachusetts are annoying.
Now, they're all wonderful human beings. All right, until you get them in cars. All right. Did you? Nice to meet you. Oh, next question. I'll come back to you and over there.
Actually, I have a lot of questions, but the first one, you mentioned, yeah, it's good. Flame retardancy. How do you make it flame retardant, and what chemicals do you use to do that?
I can take it. I'll start. Yeah, please do. So, that's a great question, and I want to know that as well. Just in general, we were talking about before, in general, when you have steel will melt in a building quicker than wood will burn through. So you get deflection in the steel because it heats up quickly and it melts. The thing with the wood is it won't do that. It will actually stand longer and be safer. So the way that that works, and this is the way it's been explained to me, and if you guys want to jump in, please do. So for our building, our shafts, where we have our elevators, we have our stairs, they're 1 hour rated. And the way that they size this lumber, you have to... What's that mean? The 1 hour rated? Yeah. So basically, the reason that our shafts are 1 hour rated, especially our stair shafts, is if you're in a fire, let's say there's a fire and you get into the stairs, you're protected for 1 hour when you're in the stairs. Same with our elevator shaft. It's rated for 1 hour. The way that this is rated is they come up with a certain thickness, and there's a charring that can happen on each side of the wood. So they do tests with, I know they did it in Canada with the, what's the testing that we use here in the States? I'm blanking on it right now.
The one I know about is done by the Alcohol, Tobacco, and Firearms.
No, there's another one. It'll come to me in a second. But anyway, they do testing on this wood where they put it through fires to see how much it chars in an hour. So they size this, let's just say, they size this to be 7 inches, right? And it can take 1 inch of burn on each side. It can char on each side, and there's 5 inches left after the fire. That lets that piece of wood stand and gives someone an hour to get out of a building. Is that a good way to say it? A better way to say it?
No.
So I just want to encourage everyone to Google YouTube, go onto YouTube and watch the Alcohol, Tobacco, and Firearms testing of cross-laminated timber. Bureau of Alcohol, Tobacco, and Firearms built
Just a little bit closer.
5 two-room apartments and furnished them from IKEA so that they'd be sort of typical. And then they set them on fire. These were 5 CLT apartments. They did some with exposed CLT, some with the CLT covered so that it wasn't exposed. They turned off the sprinklers in some of the apartments before they lit them on fire. The other ones, they left the sprinklers on. In all cases, it met their requirements, and I believe in all cases, the cross-laminated timber, after they quit applying fire and after the initial flashover, which is terrifying and happens in any closed room. That's why the fire departments all tell you to get out of the building and call 911. After you watch these videos, you'll believe them. And anyway, after the flashover was done, the CLT self-extinguished because of that char layer.
Yeah, so when CLT is made of wood and will burn. However, when we think about fire, it needs 3 things. It needs the heat ignition, it needs the fuel, in this case wood, and it needs oxygen. What CLT does is really deprive the fire of the ability to have 360-degree oxygen. So you think about a standard house where 2x4s are spaced a couple feet apart. That's a stick of wood surrounded by oxygen. This is not. This has one face of oxygen, but as Matt was mentioning, as that face burns, there's still structural integrity. This is like, when you have a campfire, the piece of cordwood you put in the campfire is burning, but it's the outside that's burning. And, the next morning when you wake up, oftentimes there's the remnant. So there's sort of a big piece in here.
This is Science Cafe, so you can mention surface to volume ratio and everybody will understand.
SVR.
Cool. All right. For them.
I'm a little surprised to hear you say that a lot of the woods in New England are not, I forgot now what the term was, buildable and whatever.
Yeah.
I'm wondering what that is made of and what are 2x4s that are commonly used made of. I thought they were fine.
No. So they could be southern yellow pine, but southern yellow pine is southern by definition. In this region, the pine we grow right around here would be white pine, the king's pine. White pine is not structural. It's not strong enough to be used as a 2x4. It's used in all sorts of applications. It's used in furniture and boxes and a myriad of uses. Also around here we have a great deal of northern hardwoods and oak and maple. Those are used in the floor, in the door, in the chairs we're sitting on, not your chairs, in the surrounding to the windows. However, the structural lumber that grows in this region, so something strong enough to be 2x lumber, really it's spruce and fir. And those in forest type start at roughly, we can go find some here, but they start roughly at the notches. So once we're up in Berlin, Errol, Groveton, Pittsburgh, New Hampshire, the Northeast Kingdom of Vermont, and really the northern 2/3 of Maine are dominated by spruce fir forests and the softwood type. So that's what we find. This out of Quebec is spruce fir. It's very same forest type we'd find in northern New England. I know Neff and others have hopes, aspirations that some of the species we grow here, notably hemlock, which is a significantly underutilized species, could be used for this. It is very likely possible long-term, but it's certainly not going to be the first use case because there's a whole bunch of code and testing that needs to be done. While right now you can go to a spruce fir mill, buy the lumber, and start up a factory tomorrow.
Can I just add on?
Yeah.
So the state of Massachusetts faces the same problem as the southern 2/3 of New Hampshire, that we don't have spruce and fir. And in the state government in Massachusetts right now, the Baker administration is very interested in having CLT used in Massachusetts, and they would ideally like it to come from Massachusetts. We keep arguing to them that it would be better if it came from Maine and New Hampshire, but anyway. So they have invested $300,000 in the lab of Professor Peggy Clouston at the University of Massachusetts, and she's just completed that testing on hemlock that Eric mentioned, and it worked. Hemlock CLT will pass the test, and so she is now in the process of getting some hemlock CLT manufactured up to the commercial standards and shipping that out to the third-party certification labs that have to approve it, and then it'll have to go before, it'll have to get approved. ANSI, I think.
It's ANSI is another one.
Yeah.
Crazy, I can't remember.
So there's some steps, but it's looking promising. Her next step is she's going to test white pine, and she actually thinks, despite it being less strong, that just means you'll have to use a thicker layup, but it might work fine. So.
All right, next question.
David, I was just going to suggest you get those photographs circulated.
Yeah.
Because one thing that you guys haven't really talked about is how beautiful the buildings are. They're striking, and there's a fantastic example on the UMass Amherst campus.
Yep.
And you're building one right now. It's being described as the first in New Hampshire, but it's not. The French wing of the Forest Society is technically mass timber. I'll say mass timber. But they're extraordinarily beautiful buildings. They're rich, they're warm, incredibly versatile in how you can utilize the structural elements and the panels. And they just have tremendous potential. Setting aside the engineering, I don't think this thing is working, David. No, setting aside the engineering attributes and the greenhouse gas or climate or carbon attributes, which I hope we'll get into, the aesthetic attributes are really pretty significant.
I mean, that's why, yeah, I mean, that's why our client wanted to use this. It really humanizes the space a little bit more. It's definitely warmer. You know, this is a material that everyone wants to be around. Our client, so they have two buildings up there. So this is at 90 Arboretum Drive. Our client built one at 100 Arboretum Drive, a regular office building, and they wanted this one to have a little bit more of a premium feel to it and a different feel. They're trying to attract a younger crowd up there, maybe a tech crowd, and they felt that this is the way to do it. They wanted to have everything exposed and everything you know, natural. So we're not doing anything crazy on it. We'll put a little sealant on this material at the end because it needs to be sealed afterwards. But I agree. The outside of this building also has all natural materials. It's got metal panel on it. It has a lot of glass on it to get a lot of light in there, and it should be a fantastic space for people to work in. It's going to be really beautiful.
You said this is a modern, and I think the pictures show it.
Yeah.
This is a modern old mill building look.
Yeah. Yeah. Yep. Exactly.
But it was aesthetic is what drove the clients as much as not saving carbon or not providing lumber.
Time too.
And time.
Time was the other issue because this goes much faster. And like I said, we should be getting the CLT at the beginning of December, and we're going to go out there and take 1 million pictures of it. But we're expecting this to go up in like 8 weeks.
As compared to if it was a steel frame building with.
Yeah, maybe 14, 12, 20 weeks. Just depends, you know.
So that's a significant monetary savings.
Yeah, especially the stair shafts I talked about before. Usually they're done with either steel or CMU, and we're talking 3 days to put up these shafts, which would take weeks. You know. Yeah, go for it.
There's a building in Melbourne, Australia that was built out of CLT, and it's a 9-story tower. They built 3 identical steel and concrete towers next to it. They went with the CLT because it was lighter weight, and therefore it was on a wharf, and they couldn't get a strong enough foundation in for the steel and concrete, but because the building's lighter, they didn't need as much foundation. That one went up in 27 work days with a crew of 4, as opposed to the steel and concrete buildings, which took 6 months each. But the real difference was the crews, you know, the electrical, the plumbing, the finish crews could get in under the guys who were working right above them, because the CLT, I mean, imagine you've got a floor above you that's made of that. You don't have to worry about somebody dropping a wrench above you the way you do if it's a steel frame building and you got all these openings.
Oh, cool.
So it goes up faster, both because it just goes together like Tinker Toys, but also because the process is better.
Cool.
I know up in Maine, they've been doing, canoeing the Allagash up in the Great North Woods. They've been using, I believe, this type for some of the bridges, and my understanding is that they've tested out as strong or stronger than some of the concrete bridges. You know, when you have those, up in those areas, they're private roads, and they've got, giant lumber trucks. And I mean, I know that goes back to, at least the early 80s, and beyond. And some of the bridges are still well used. And I know up at UMaine, they've got quite an engineering lab, and I know they've got quite a, testing, and they've been using there are some of the buildings. I know especially the forestry building, Nutting Hall, was built, that was 40 years plus ago of the same. And I know a couple of years ago, it still is in fantastic shape. But yeah, I mean, I know, because what is it, in Europe, I was reading a couple days ago and hearing about this, supposedly there's I can't remember what Scandinavian country, but supposedly there's a 16-story building that they wanted to be putting up.
There's actually now an 18-story building in Brumunddal, Norway, made out of CLT, tallest wood building in the world. It beat out the Brock Commons in Vancouver at the University of British Columbia, which is also 18 stories, but it's shorter. So, and then there's a 14-story building in Bergen, Norway, that I've actually seen, and man, is it beautiful. It's the prettiest building in the downtown.
And when we think about this region, when we think about northern New England, if you ignore the fact that Boston exists, which we shouldn't do. I like Boston, like where would you go see the Red Sox? But if you ignore the fact that Boston exists, all our cities, Manchester, Portland, Burlington, Hartford, Springfield, Worcester, are, 18 stories would probably be the biggest building in every single one of those towns. We're mid-rise. When we think of big buildings, we think mid-rise. This could build almost every building in New England, and it's certainly in the 2, 3, 10-story space. There's enormous opportunity. But that's not the only opportunity. University of Maine is considering a project now that's a 2-story classroom, not unlike every other building, but made of wood and looking fantastic. Again, a strip mall, a new grocery store could be built out of this. And it really, aside from the traditional single-family residential, which is stick-built, traditional wood construction. This really makes most of what we do in New England.
All right, I got a question here.
So when I'm hearing you talk about how these are built, it's with spruce 2x lumber,
Yeah.
right? Well, that's not, in my mind, as a forester, low grade, right? So what I want to know is, so how can we apply low grade and develop low grade markets for this?
So I'll start,
Yeah,
and then
luck.
I'll let Eric go carry it off from there.
Frank, just say what low grade is.
Oh, sure. Low grade is the material that's not, it's not high grade. It's the
All right, well, we're covered then.
it's the
Thank you,
small-
Professor.
It's the smaller trees. It's the trees that there's not a strong market for. It's the trees that aren't saw timber. You're not going to cut them into lumber. What are you going to do with them? They end up in cordwood. They end up busted up into chips and then burned as chips or used as mulch. They end up being used to make pellets. The trees that are not, they're twisty. They're not going to make lumber. So what are you going to do with those?
And none of those are terribly make a lot of money for the forester, or the landowner, is that correct? Or
They don't make a lot of money for the landowner, but they're important to the forest economy, because if you want to grow saw timber, and you want to grow a lot of it, and you want to grow it nice and straight, and you want to get a good return quickly, you have to thin your forest just like you thin the spinach in your garden. And so you need you either are paying someone to do that, at which point your returns go through the floor, or you've got a market for those low-grade materials. Even if you're just getting a few pennies, at least you're not paying someone to cut them out, and meanwhile that's encouraging the rest of your trees to grow. So low-grade markets are super important. The pulp market has been kind of sad because the paper mills all over New England have been closing down. Paper mills aren't particularly a wonderful thing environmentally anyway, and we all know we're going to a digital economy, so in the long run, That's not our solution. So what are we going to do for low-grade material? So first of all, there are CLT applications for low-grade. The University of West Virginia and the University of Indiana are both doing work on how you can use hardwood lumber, particularly red maple, in CLT, and they've got promising results. There's a lab at MIT that is actually working to use ultrasonic beams? I don't think that's the right term. They're using some sort of sound energy, ultrasonic energy, to straighten curved pieces of hardwood, and specifically so that it could be used in CLT, straighten the grain. I don't know if that's going to work, but it's interesting. So the other thing is what other low-grade markets are coming along. There is now a wood fiber insulation plant that's about to open up in Maine. Eric probably knows where in Maine. Madison. Okay, there we go. And that's a nice market for low-grade material. And that's, why are we using fiberglass and cellulose and other things that have a high energy input? It's the same logic as using this stuff in place of steel and concrete. Instead of heating steel and concrete up, instead of making steel and concrete, which requires heating the material to 2,500 degrees Fahrenheit, we can make this instead of making fiberglass, which requires, it's glass, right? It requires melting it. We can use wood fiber insulation.
All right. Oh, you want to go ahead?
Yeah, quickly. One, just because we're being recorded for posterity, I'll sort of just generally disagree with you on paper markets, but that's not tonight's subject, so we'll leave it at that. That said, long-term, I think we're going to see an awful lot of low-grade species, but it's still going to be saw logs. It's going to be underutilized species going into this. However, and Frank and I probably disagree here, I don't see the first use cases in New England. If a developer came to me and was like, hey, I want to do a hemlock and red maple CLT plant, I would beat them around the head and neck and talk to them about doing spruce fir, because you can do it and it's non-problematic. Do I want to get there eventually? Absolutely. Do I think we're going to get there eventually? Absolutely. However, you are 100% correct in that the first use cases are going to be using existing structural lumber, which is spruce fir, which is it builds an existing market for spruce fir saw logs. It doesn't help us with our hemlock or our low-grade issues.
Okay.
I'll just add one thing. First of all, I don't disagree. I think these other markets for hemlock and such are several years off, if not a decade off. But the New England Forestry Foundation, with funding from the U.S. Forest Service and with help from INRS and the company Pori out of Finland, did an analysis of the cost effectiveness, the potential to make CLT here in New England and have it be cost competitive. And we can do it. But one of the pieces of that study that I really loved was if we could get this hemlock CLT to work, we could undersell the world. We could export CLT everywhere else and have it be the cheapest product on the market.
Unless the hemlock woolly adelgid kills them all off, but we won't go there. So, all right. Did you have a question? Yes. Let me go back here, since you've already asked one. Yeah.
So I'm just wondering if you've probably done some sort of study comparing the wood and the engineered wood structure, building structure, compared to steel. Does it last as long as well?
So I'll start and then I'll turn it over to these guys. Maybe you want to go first?
No, you take it.
Okay. The building code in the United States is governed by what's called the International Building Code, which just means that it applies to the U.S. and Canada. And that's governed by the International Code Council, which just did a pretty deep dive on this exact question as part of what's called the 2021 revision to the International Building Code. And that was just approved this year so that people can get ready for it. And that 2021 code not only allows for 6-story CLT buildings, which were also allowed in the 2018 code, it creates new categories for 9-story, 12-story, and 18-story CLT buildings with different requirements. And so they made I'm no expert in steel and structure, but they are, and they made the judgment that yes, this stuff is going to be safe, it's going to be strong, it's going to be durable, it's going to be effective.
I'm not adding to that. That was perfect. That was a great answer.
But obviously, you wouldn't have agreed to build it if you thought it was going to fall down in 5 years. I mean, you know.
No, if I just think about buildings, I mean, there are several buildings in New England and around the United States that are built of oak that are 200 years old. You know, so now you have an engineered product that's wood, and it's in a sprinklered building. The building that we're doing in Newington is actually sprinklered as well, so that should stop any of this from catching on fire. You know, time will tell, but you know, that's a great answer. If the IBC or the ICC Council thinks that, you know, these buildings are going to last that long, they're willing to put that in a code, which New Hampshire is using 2015, just so you know. IBC was just adopted in September, which does have a provision for CLT, and it only gets there's only more and more for CLT, but yeah, I think it's a great product. I'm very excited to see this building go up.
Excellent. Let me get some other, you've already asked, here's one over here.
Is anyone designing a building where the bottom, say, 20 stories are cement, concrete, steel, and the top 18 whatever stories are CLT?
I mean, I can say that quick. Yeah, they wouldn't do it exactly that way. They're doing what's called like a 1/3, which is basically you have a concrete, let's call it a bunker or a parking structure underneath the building. So you build that out of concrete and steel, traditional construction, and then everything above that is traditional wood framing above it. So it's actually pretty popular right now, and we were just talking about a little bit before. There are some issues with it because during construction there was one in Massachusetts that caught on fire right at the end because the sprinklers weren't turned on, it burned down, and then that's actually caused a lot of issues with now having to have fire watchers. So it's kind of a newer construction type, but I don't know if you want to add to that.
I'll just add 2 quick things. One is that building that burned down in Waltham, it was not CLT, it was stick-built with the lots of air around the wood, like we talked about before. And B, they've now determined that fire was arson. So I don't put too much concern on that. The other thing I'll say is there is a building that I just heard about that's going up in the Midwest, and I'm struggling to remember exactly where, but I believe it's 3 stories of concrete with, I think it's 15 stories of CLT above that. So that'll be a pretty big building. That'll be the biggest one in the U.S. at that point.
Excellent. Okay. Another question. Here's somebody hasn't yet.
The question I'm sure most developers look at is the ultimate cost difference. I can see that obviously you're going to save on the construction side of it. Is there enough savings on the design side? Because I'm sure it probably takes maybe a little bit more time to design the CLT steel wood structure, but is there a large cost difference, or what's the primary factors from the cost side?
I'll let you answer, but first I'm going to step in and say the projects that I've had some insight into, the material's more expensive, the construction is less expensive, and the time to get someone in the building, it isn't really an expense, but is a cash flow issue. As labor becomes more and more constrained, the time to construction probably becomes more important. Additionally, once we get a CLT plant in Maine, and then one at Pease, and one in Massachusetts, it's going to drop in cost, because right now, to get cross-laminated timber, you're getting it from Montana, you're getting it from Quebec, and not the part of Quebec any of you have been to. like you just keep going north, and once you hit the Arctic Circle, you're there. Or from Austria. So the shipping is very expensive. All of that, once we have some regional, it's probably not going to be local, but once we have some regional construction, it's going to drop.
Yeah, I agree with that. I was doing a little studying today, and I did see that a traditional office building, steel composite deck construction, was 25% more than a CLT building. And Eric made a great point. Having the quicker construction is nice too, because the developer has interest on his loans every month, and the quicker he can get in the building and quicker get tenants in the building, those are costs that he saves. So there is a savings to it.
I'm sorry, did you say it costs 25% more less for steel and concrete? No.
This is 25% less.
In terms of materials and time and construction cost, really?
I just read it in.
Well, that's a huge difference.
I would think so, with the price of gas and having to come down from Canada.
I know that UMass originally designed the John Olver Design Building, which is cross-laminated timber. They originally designed it out of steel and concrete. The reason it's named the John Olver Design Building is former Congressman John Olver intervened to get some extra funding so they could build it out of CLT instead. And it turned out to be 5% more than their original estimates once they redesigned.
Steel and concrete estimates.
Than their steel and concrete estimates. Now, mind you, that 5% increment includes redesigning the whole building after they had already designed it for steel and concrete. So I'm not sure that it would have been any more costly had they started with CLT on the front end.
Excellent. All right. We got one over here that hasn't done it yet.
You talked about the structure, so we're thinking of the up and down pieces and then the decks. How about the walls in between those up and down pieces? Is that intended to be used for walls? And then the second question is, can it be visible on the outside, these big beams? I mean, is that the way that architects are designing it, so you can actually see those beams from the street?
Yes. In the renderings that went around, if you didn't see the exterior rendering, we have a large glass corner piece there, and we are exposing the wood here. Now, our beams are 32 inches deep. You're not going to miss those. Our columns are like 9 by 11. That's very big. And then when you add the CLT slabs that are also, 6 and 7/8 deep, you're going to see all that. So yes, we are exposing that. Then inside the building, so I was telling these guys that this piece that you see up here, this is their sample piece. So someone took the time to sand it and make it really nice. The way that you normally get this was with one side that's called architectural, which is a little bit nicer. They probably plane it down and make it look nice. And then the other side is just, it's the lumber as is. For us, what we're going to do is we're going to put the architectural side down to make the ceiling, and then we'll put the non-architectural side up. Because for us, just one other thing on this that's important to note is this is great for acoustics because it's so thick, it has a lot of mass to it. So what we're going to do to give it even a little more acoustic separation from the floor below is use a 3-inch concrete topping slab on it. So that's another reason why we wanted to put the architectural side down and the non-side up. Walls inside the building, when we use it as a wall at our shafts, if I lift this up and use it as a wall, we're going to expose it inside the stairs, but the client might decide in some places to cover it with sheetrock if it doesn't look that nice. And I really suggest if you don't know a lot about it, hop online. There's a lot of great pictures of buildings, especially the UMass building. There are several construction photos that let you see how the building goes together. The UMass building is really interesting because it's kind of a hybrid building. Has a lot of steel structure to it, but it also has a lot of CLT to it. There's another building they just did in Providence. I don't think it's at URI, but it's a building they just did Yeah, Rhode Island's called RISD. Yeah, Shawmut Construction just put it up. It's on their website. Again, that's a hybrid. They use the steel structure with the CLT slabs for the floors. So definitely take a look at the material. This is a little deceptive because it looks nice, but it's still a natural, beautiful product, and I think that at the end of the day, it will look really, really terrific.
Just worth noting on that RISD building, it started construction in June, and I started writing an op-ed for the New York Times on this CLT stuff in August, and didn't catch that between August, when I wrote the first draft, and October 3rd, when the thing published, that they had finished the building and put students in it for the fall. So they started in June, and in August, at the very end of August, they had students moving in. That's crazy fast.
That's great.
Excellent. All right,
Also
question over
resulted
here.
in me having a correction, which...
Okay. I actually have two questions. One to take off on this gentleman's. When you have vertical columns, do you finish all four? Do you finish? Can all four sides be finished and then stained or whatever, or does it require a laminate or veneer on it? But my main question is susceptibility to environmental factors such as moisture, rot, insects, termites, and movement as a function of temperature change.
That's a great...
Oh, earthquakes. We're going to throw earthquakes into this, too.
Are we going to talk seismic? I would love not to. You can talk seismic, please.
This is New England. We can ignore seismic.
I mean, we should talk about it. I'll let these guys talk about it. But, in terms of expansion and contraction, that's an interesting question that you asked because, again, our cores in the building, our bathroom cores, are made of the CLT walls. And one of the things that I was concerned about was putting tile on the walls. You know, how does the CLT expand and contract when I put grout on the walls or mastic on the wall and put the tiles on there? So what they suggested that we do is actually put a layer of sheetrock on top of it. So the sheetrock will absorb that and it won't be a problem. So that's why we're going to use sheetrock in some areas, but we'll use it sparingly. And then, what was the second part of your question? The finish on the columns.
You mentioned polishing one surface. Like
Yeah.
the bottom of the
So the columns and the beams will come as an architectural grade. You can get different grades of glulam beams. So if it's a glulam and it's going to get covered, you don't care about the wood. It doesn't matter if it has finger joints in it. It doesn't matter about knots or any of that. But when we get it, we'll get an architectural. So all you have to do is just seal it, and it will look fine.
What about rot
And ants and
I'm going to
insects?
pass that over here to these guys.
Let me start with earthquakes because I know that better. So there's a lot of excitement on the West Coast and in Italy, two very earthquake-prone regions, about building with this stuff, and in Japan. And there are a few reasons for that. One is it's much lighter than a steel and concrete structure. So when the earthquake sets the building rocking back and forth, there's much less loading, much less force. You know, force equals mass times acceleration. You got much less mass. So you have much less force, so much less probability of the whole structure crashing to the ground. The other thing they've realized is wood, as you guys know, has a little bit of flex to it. And so they are doing these hybrid connections in a new building in Oregon. I think it's in the Carbon 12 building, where they've actually put a metal fuse between the pieces of CLT. They've put a piece of metal that they know is going to break because it's brittle as compared to the wood. And then they'll be able, after a major earthquake, to just pull that piece of metal out, stick a new piece of metal in its place, and the building will be functional again without having to tear it down and rebuild it. So earthquake-wise, vast improvement. In terms of rot, what I've been told by CLT experts is, you need to protect it from water, but you need to protect concrete and steel from water as well. Steel rusts, concrete rots, in a different way than wood rots, but, same thing. I personally am curious to see how the insect problem plays out in places like New Orleans with the the new Asian termite that they've got that's very aggressive. But I'm less worried about that sort of thing here in New Hampshire, at least for now.
Actually, let me follow up on and ask you, because when we were talking briefly, and you were talking about the flexibility of wood, you talked about how you have to design it differently for wind and
Oh, yeah.
because than you would if it was a steel frame.
So this is just an interesting thing. When I was working with our structural engineer, he was questioning the loads on the building. He's like, I can't believe these loads on the building. Why are they asking for such large foundations and footings? And it was because the building is so light. A steel concrete building is very heavy. So he had to beef up the foundations in the building just because of the wind loads, so that, you know, quote unquote, the building doesn't blow away. So they had to make the structure much bigger, much denser, much thicker in order to hold the building down.
And how about sway in terms of if wind comes along, or is that an issue? Or you're not going to get seasick on the top floor?
No, not in this building. This building is pretty stout and low, but I would love not to go into the lateral bracing on this and how it works. Ideally, if I was to do it again, I would probably rethink the stair and the elevator shafts being done out of wood, just because it's good, but it requires a lot of extra thought. It's better to do it out of poured concrete, your elevator shaft and your stair shafts. First of all, you get the ratings built in right away, and those, because they're so rigid, it gives you that shear that you need it stops the building from shearing back and forth. So I would probably think about that. Again, it's not the most green thing, but it also gives you a little more flexibility in design,
Okay, great. Question over here, and then I'll come up front.
Speaking of green, I'm concerned. I was wondering about the glue that keeps things together, and along with that, how are you fastening these pieces together?
If you want. I have no idea about the glue, so I won't lie. I don't know. But these guys might know better than me. But the connections, actually really standard connections, they pretty much use really long screws to put everything together. It's amazing what they're going to do. Like I said, for the beams, it's going to just sit right on top of the beams, and it's going to get screwed down. We have ledger boards right at where our shafts are, because our shafts are going to go up first, and we just have ledgers, and the CLT slabs sit right on top of the ledgers. The way that it connects to the footings, there's a plate that goes at the bottom of the column and then attaches to the concrete footing. It's pretty ingenious the way they do it, but it's like a big house. I don't know, is that a good way to say it? It's kind of like a big house with some things a little bit different, but I was very surprised when they showed me the connections. They use a lot of splines, pretty traditional woodworking things. I don't know if you want to add to that.
Well, if you think about it, this is mass timber, right? Well, what else is mass timber? Like every colonial barn ever built in New England. And so, interestingly, with the UMass building, Bensonwood here in New Hampshire did a lot of the design and training of Suffolk Construction, which is the big construction firm out of Boston, about how to do the connections of these big glulam beams, which are just the same as post and beam construction in terms of how you work with them, to the concrete foundation. So local New Hampshire knowledge to the rescue. I guess in terms of glue, when CLT is a relatively new product. Mass timber in various forms has been used forever. Most mill buildings in New England use nail laminated timber floors, for example. But cross-laminated timber, as I understand it, was basically invented in the 1990s, started being used in structural applications in the early 2000s in Europe. So it's pretty new. And when it first came out, there were two kinds of glues that were used. There was a formaldehyde-based glue, and there was a polyurethane-based glue. The formaldehyde-based glue, it turns out, if you burn it, it releases formaldehyde. Not a great thing. So everybody has gotten rid of that and shifted to the polyurethane-based glues, which when they burn, they just release carbon dioxide and water, and they're water-based polyurethanes, not oil-based ones, and they're pretty innocuous.
All right, I got a question up front. No No other first-time questioners?
We haven't talked about carbon yet, and I dare say that these buildings are going to be much less expensive than steel and concrete when, not if, but when society puts a price on carbon. And I wonder, Frank, if you could explain why that is.
Okay, so first of all, I agree. So why is that? These buildings help save the atmosphere and save the climate that we all know in 3 different ways. First of all, like I mentioned before, when you make steel and concrete, either one of them, you have to heat to 2,500 degrees Fahrenheit. That is typically done by burning coal. There's all kinds of technologies that the steel and concrete industry is working on as to how they could make steel and concrete either with electric arc, things that are fueled by solar panels, or with direct solar ovens, where you might focus 1,000 mirrors onto one spot and create intense heat. But those are decades off from being commercialized and in use. And we don't have decades. You know, the IPCC report that came out last October showed that we might cross the 1.5 degrees Celsius threshold that scientists warn us is where we're entering the zone where we might see very rapid and dangerous climate change, that we might cross that as soon as 2030. And that report said that we need to get to net zero emissions by 2040 to have any chance of staying below that 1.5 degree threshold or getting back to it by the end of the century. So net zero by 2040, that's like around the corner, and 2030 is even more around the corner. I mean, my middle school kid will be in college in 2030, and I'm already saving for college. What am I doing about the climate for 2030? So that eventually we might be able to make steel and concrete in a carbon neutral way, but that's a ways off. Right now what we can do is substitute this for steel and concrete and save a lot of carbon emissions. The second way it saves the atmosphere is that is a lot of carbon. That's a block of carbon. It's not just a block of wood. It's 50% carbon. And if you make a wall that's 9 inches thick and 8 feet tall and 60 feet long, that's a lot of carbon. And so these buildings actually sequester carbon. The Brock Commons, that 18-story dormitory in Vancouver, sequesters 1,753 metric tons of carbon in the structure of the building. So it's a way that we can take the almost magical ability of trees to draw carbon dioxide out of the atmosphere and turn it into wood. We can take that wood and store it in our cities. We can turn our cities into carbon stores to save the atmosphere. I'm way into that. The third way is because this makes mid-rise buildings more affordable, we can put up mid-rise housing. I don't know how many of you ever drive into Boston, but if you drive to the ends of any of the T lines that run into Boston, they're all surrounded by these 5-story apartment buildings because that's what you can build stick-built. And you don't build steel and concrete housing much below 12 stories because it's not cost efficient. So there's this gap of 5 to 12 stories that isn't getting built. And so to find affordable housing, people are driving into New Hampshire. And I was driving right along with them tonight. Well, that's also true. It's renewable. After we harvest the forest to make these, the forest grows back and sequesters more carbon. New England Forestry Foundation has just done an analysis of how much more carbon could we store in New England's forests by applying the principles of silviculture, by the forest science. How much more carbon could we sequester with better forestry and still produce wood, so produce as much wood? And the answer is astounding. We could sequester an additional 1.9 gigatons of carbon dioxide equivalent. Just so, what's that mean, 1.9 gigatons? Well, on a global basis, we emit about 40 gigatons a year. So right here in New England, we could sequester as much as 5% of the world's annual emissions. It would be equivalent to taking every car, truck, and tractor in New England off the road for the next 20 years.
And can I just say that this is a large part of the reason why I wanted to do this particular Science Cafe, and I've been writing about the topic a bit, and we'll write about it more. All the global studies I've seen, an attempt to avoid complete and utter catastrophe for our grandchildren. One of the things is changing the built environment. 2 billion more people are coming. They're going to need places to live and to work and to shop. We're going to have to build lots of buildings for them. If we're doing it out of concrete, we're screwed. So the more of this we can do, the sooner, I really think, is one of the major changes that needs to be made by society.
My boss is fond of saying if we build them all out of concrete, we're cooked.
Screwed has more impact. Plus screws and wood, It's anyway, all right, so, okay.
Did you want to add anything?
Nope. Why would I?
You just mentioned that you could use this material for building walls, so I'm assuming that you can get it in various thicknesses to vary the thickness of the wall.
Yep.
What about the R value? How is it from an insulation perspective?
That's a good question. We're not using it on the exterior of the building right now, so that doesn't really play into it, but we are using it on our roof. We have a sloped roof, but it still has 5 inches of rigid insulation above it. These guys could probably answer a little more technical, but it does have an R value to it. It does not have the same thermal properties as concrete and steel. If you've ever been on a construction site and you go in a concrete and steel building on a day like today, you are like in a refrigerator all day. It's horrible. This does not have the same thermal properties as steel. It's more stable. It doesn't absorb the cold as much. It's a better material. That's not a great technical answer. You probably can answer it better. Do you want to answer it?
I don't know anything about it.
So it's basically more comfortable to be on the work site during it, do you think? Or is, it's subjective, but...
So, to answer the technical question about the R value, it's the same as a 2x4. It's about R1 per inch, which isn't great because, this whole thing has an R7, which is not, you need more than that. So that's why you have the rigid insulation on the outside. The University of Maine, at their composite lab, there in Orono that this fellow over here mentioned before, they're doing research on could you make CLT with some of that wood fiber insulation as one of the layers, so that you could increase the R value and still have sufficient strength for walls. But that's research. It's not on the market today. So right now you put insulation on the outside. The other thing I'll mention is at NEF's headquarters in Littleton, Massachusetts, we have 2 tiny little CLT huts that were built by hand. They actually made the CLT right on site by 3 graduate students at the Harvard Graduate School of Design. And what they were doing with it was exactly what Matt was referring to. They were testing the thermal properties, the thermal experience of being in the building and how much heat you radiated and experienced. How did you experience cold as from the walls or heat from the walls as compared to a traditional building? And they found that it was that whatever, they had lots of fancy statistics. Their fancy statistics showed that it was more comfortable, more for the occupants than a traditional building.
Any newbie questions? Well, I'll come back to it.
Okay, thank you. I forgot my question. No,
You left it in the microwave.
wait a
That's why I always
minute.
put
Wait a
things
minute. You mentioned earlier I was so involved in your answers, I wasn't thinking about the question. You mentioned earlier that a possible processing plant for New Hampshire, for instance, was going to be in peas.
I said could be in peas.
Could be in peas. Okay. Food for thought. Where the source of the material is in our north country, north of the White Mountains.
Yep.
Having processing plant up there, I'm just planting a seed. There's a shortage of job opportunities. It would help the state and our residents up north if there was a processing plant, and we have a community college up there. If there's any additional technology, technological education, blah, 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 they would jump on it. They would absolutely jump on it.
Absolutely. So let me start by saying I don't have the $20 million to build the plant, so I'm probably not going to eventually make the decision. However, work I've done for NEF and work I've done for private industry show that you want to build a plant between the sawmill and the market. And in all honesty, the big dog in the market is Boston. So when you draw a line between Milan, New Hampshire, and Boston, anywhere along that line, Dover Foxcroft in Boston, Ashland, Maine in Boston, these are where the sawmills are. But you draw a line between the sawmills and Boston, that anywhere along that line, and it sort of doesn't matter so long as you're along that line. What you don't want to do is draw a line from all the softwood sawmills, which are Milan, New Hampshire, or the northern half of Maine, and Boston. And when you look at that line, decide that Hartford, Connecticut is the right spot, right? So that's the out. A reason, well, we're not citing a plant. There are reasons to think about putting something not right by the resource and closer to market. However, I completely agree that the economic development opportunities, 25 jobs, which is plus or minus how many you're going to have at a CLT plant. These aren't 1,000-person facilities. 25 jobs in Berlin, New Hampshire, Groveton, New Hampshire, Milan, New Hampshire is a lot more than 25 jobs in Portsmouth, New Hampshire, or Portland, Maine, where I'm from. So that is absolutely correct. Recognize that. All that said, someone's going to make a absent economic development intervention. Someone's going to make a market-based decision on where to put a plant.
Well, this is New Hampshire. We're always happy to subsidize things and hand out money. We do it all the time.
You're famous for it.
Yeah, famous for it, absolutely.
I'll just add that the study that Eric was part of, that for NEF, did show that you were going to have a much higher rate of return if you could redevelop an existing site rather than, create a new plant, a new factory out of whole cloth. So that further limits your options to some extent.
All right, over here.
You mentioned back in the beginning the process of creating these structures in the factory or whatever you call it. Are you using, I assume you're using cheaper labor than if it's out on the site. I was right next door to a new school that was built with steel, and you had people, I believe, were, iron workers, union workers, assembling these pieces on the site and going up and hanging them around, and they knew how to weld, they knew how to put on bolts and stuff, and I assume it was very high-paid work. Is it kind of like manufactured housing where you can have cheaper labor, maybe even avoid the real trades when you're building it in bulk in the factory?
So many of these jobs are skilled positions, so it's not necessarily cheaper labor, but it's much more efficient in that you can have all the machinery, all the technology in one spot, as opposed to when you're building a steel building, you're effectively a little factory that's wildly inefficient because you've got to take the welding machine up to each weld, as opposed to having it all right there under the roof being done. So in terms of dollars per hour, it's probably about the same per employee. However, it's much more efficient to do the manufacturing inside in a factory environment than it is outside having to deal with weather and inefficiencies and literally carrying things around, like with people to move stuff.
I would just add to that from the design side, the way that we work as a firm, I mentioned before, we use the virtual design. So we're literally designing all this three-dimensionally. And the challenge on this project was getting the penetrations in the beams ahead of time. So in some of those renderings that you saw, there was a lot of ductwork on the ceiling. We had to get that ductwork to go through the beams. So we modeled that all on the computer three-dimensionally. We were able to check it all on the computer, and then the manufacturer would take that information and they'll use their CNC routing machines to cut all those holes. All that work will be done, as Eric was saying, all that work is being done in a controlled temperature, controlled and temperature-controlled facility. These guys that are steel workers,
Not this way.
Yeah.
Someone's hands.
Right. It's all done by machine, and that makes for a better product. Not that the buildings they build, traditionally are not, but it's a tough job. It's cold outside, it's hot outside. You got all these things to deal with. It's windy, it's raining. When it's built in that factory, it goes a lot quicker to build it, and then when they bring it to the site, they've essentially built it once, so they just need to erect it or assemble it. So, there are some efficiencies to it.
I've been hearing about doing this for housing my whole life. We're going to have manufactured housing, and it'll be cheaper and better, and it's never seems to have worked at the housing level for whatever reason. But
I mean, there are SIPS panels, and there are things you guys can talk about that too. That's great. I would love to build a SIPS panel house, but I wouldn't even know where to get it. I wouldn't even know how to start as a homeowner. So, this is becoming more readily available for developers and construction teams. Like Frank mentioned, Suffolk Construction down in Boston has done a building, and now Shawmut Construction down in Boston has done a building. These are really big general contractors, and the fact that they're getting their feet with this already is amazing. Our developer, Farley White Interests, the fact that they're doing this now, they'll do more buildings with it. So the fact that it's readily available and it can just be a commodity product makes it easier for people to use, and designers like myself, we want to use it.
Sigmund's doing a project.
Yeah, absolutely.
I'll just add that to again plug Bensonwood, they've created their Unity Homes division and created a new factory in Keene to build homes that will essentially be, they'll use glulam beams, they use some CLT, they're using as much wood in them as they can, but they're prefabricated in the factory in Keene and then assembled on site. I've been in one of these homes. It's one of the most beautiful sort of low-cost homes that I've ever seen. And so maybe we're getting to a place where that dream you've been hearing about is going to come true.
Frank Lloyd Wright would be so happy.
This product can also be used as floor. Is it ergonomically better to walk on than concrete floors? Or is there a difference?
It's slightly different. That's a great point. When you are constructing this, acoustically, it's a good acoustic product, but there are some issues with vibration. It's very similar to a wood floor in your house. When you walk on it, footsteps will transmit through it. So a lot of times what you do when you're building your floor sandwiches, you have your 5-ply CLT slab, and then you put a vibration isolation mat between this and your concrete topping slab. So when you walk on the concrete topping slab, that vibration isolation layer will take that away, and you won't hear footfalls underneath. But you would want to do the same thing with a concrete slab as well. You want to try to, footfall is a big issue just that we need to worry about when we're doing Class A office buildings.
Excellent. All right. Here, another one here.
So it sounds like, was this your first CLT design? What's the learning process if a firm's trying to get into that? Are the developers not going for it as much because it's not, obviously you're trying to educate everybody, but is it the learning curve that was difficult, or?
I don't think it's not difficult. It's actually the same exact process as designing a traditional steel building. You're just substituting materials. For me and our team, the challenge again was working with the fabricator in Canada. We had to learn from them, and there are books that are like hundreds of pages to read about this, from structural to fire resistance to coordination. Something interesting to note about this is once this gets to the site and gets erected, you can't just drill holes in it anywhere you want. So you really need to do that coordination up front, and you need to understand what the criteria is if you do need to drill a hole in this after the fact. So our partner, Nordic Structures up in Canada, they're very helpful in answering questions. And yeah, there's a little bit of a learning curve there, but again, it didn't really change our process. We're still using traditional rain screen on the outside of the building to clad the building. We're using traditional curtain wall with SSG glass on the outside. So it's not very, very different. It's just going to be quicker. And, there should be no surprises. I mean, it's been designed in the computer three-dimensionally, goes to those guys in Canada. They have a 3D model too, and we're looking at it back and forth. So there's just a few things that are different, but not much.
Well, actually, let me follow it up. So what is the thing, can you think, what is the thing that is most different about designing this building than if it had been a steel and concrete traditional?
Nothing really.
Nothing really.
It's not radically different.
Did you know that before you designed it?
No. Personally, what I did was I got as much stuff as I could to read about this. There are a million articles. There's a million lesson learned slideshows on it. T3 has a whole slideshow. T3 is a CLT building in Minneapolis Minnesota that has. No, it's Minneapolis, sorry. That has a whole bunch of documents on it. So I'm not the first guy, and people have, learned these lessons already. We also worked with some consultants that worked on the UMass building. So we have a co-consultant that we work with, and we said, hey, what did you learn from that? What were the problems there? And some of the problems were, getting that coordination right up front. So I was hyper-focused on making sure that everyone bought into this, and we all designed it 3D, and we were able to look at each of the components. So our mechanical engineer, they modeled every single piece of ductwork, every piece of conduit, every piece of everything, so we could make sure we know it was going. But we would do that for other buildings too. Our client was demanding and wanted to see what these things would look like, so I don't think it's very different at the end of the day. It sounds like it is, but it's not.
Cool. All right, question here.
Kind of related to the same thing, but what prompted you to go to this type of construction as opposed to not doing the standard thing?
So I'll let you answer the specific case, but in general, what we're hearing, and I'm part of a group in Maine that's working on getting some CLT buildings built there. What we're hearing, the advantages are speed of construction, a aesthetic, so how does it look, feel, do you want to be in this building? And as almost a throw-in at this point, but I think will become more and more important, the carbon sequestering principles, which right now you hear blah, 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 and carbon. And I think people are saying carbon because it's true, but it's a nice throw-in at this point. I think 10 years from now when you ask that question, it's going to be carbon, then speed of construction, then aesthetics. But you can talk about your particular.
I mean, the client asked us to do it, so that's why we used it. I mean, I think that this is a great use of this kind of smaller sized building. Steel will always be here. There are always going to be taller buildings, and it's always going to need to be something that is used. And the guys that put it together are very skilled that do it, and they do a great job. But for this particular project, this was what the client asked us to use, so we were happy to take a look at it.
I agree with Eric's points completely, except that I think the switch to carbon is going to happen faster than 10 years from now. But there's one other benefit, which is a lot of builders are going to LEED construction, and a lot of communities are now beginning to require green certification, which is LEED certification typically. There's others, but that's the dominant one. LEED gives you credits for using renewable materials, to the point this young lady here made. then CLT counts as a renewable material, as long as you're buying the CLT from, I think it's from the original sourcing has to be within 500 miles of the site. And then there's the manufacturing has to be within a certain distance of the site as well. So that's another driver for why people want CLT mills here in New England, is so that they can get that LEED credit.
So before I go to the question here, I can just say there's a number of cities, in Concord is one of them, that said we're going to do 100% renewable energy and green because it's a climate emergency, as indeed it is. Something your local city could do is give a financial or other incentive to builders, saying, you're going to build a building here. If you build it out of CLT, or at least a portion of a CLT, we will remit your building inspector costs or something. I mean, that's expensive, and so other taxpayers will scream. But that's the sort of thing that you can put pressure on your local, your city council to do.
There's a lot of potential policy things that could be done at the city level or the state level.
This is an area where cities could really lead, I think.
Yeah, preferential purchasing policies like you're describing, but also just, for municipal projects, schools, city buildings, require that a wood alternative be one of the responses.
Before I go to it, I saw a piece today where it talked about how, was asking about how come there's more of this in Europe than the United States, and they said they thought that one of the arguments this guy made was that the request for proposals procedure methodology we use is inherently not innovative, because basically you say, I want this building, and you choose, and everybody says, well, I can build it this way, cheap, and then you take the cheap people. So
I'm sure that's true, but there's another factor. The EU now requires that every building above a certain size, and I think it's a pretty low size, has to sequester carbon.
Really?
So, if you're going to sequester carbon, you have to have,
That's an easy way to do it.
basically have to have more wood than any other material in the building.
yeah, I could see New Hampshire doing that, no problem.
Concord could go first.
Yeah, they could. I mean, you want to be a
Like
leader.
if I wrote for the newspaper, I might suggest that.
No, because nobody does pulp mills anymore, so there's no newsprint.
If I wrote for the website.
When you talked about it as being used for flooring, one of the first thoughts I had was the ability to laminate your finished floor on top of that, like redwood oak or whatever laminated material you'd want to put down for a flooring. But you just said that you put concrete on it. So I have, so I've got the three questions. Can you do the regular lamination, like a wood floor? And then two, how thick of concrete would you be putting on there, and why would you put concrete on there?
So a couple of things on that. We're putting concrete on top of it for acoustics to help to make that mass thicker. We are using a 3-inch topping slab on top of this. You could use more if you wanted to run conduit through it for electrical. And with concrete, you could put carpet on top of it. The aesthetics of this building might just be a polished concrete floor, so you might not have to do anything on top of it. Maybe put some carpet where your workstations are, but just pretty straightforward. You really would never be walking on top of this, ever. You wouldn't be walking on this actual surface. We're going to actually use an EPDM or some kind of waterproofing between this and the concrete, because you don't really want to get water on this product once it's installed. Did I answer it? You could put a 3/4 floor on top of the concrete. You'd obviously want to put some kind of vapor retarder between the concrete and the wood, because there's still moisture in the concrete, but you probably would not put wood directly on top of this.
That's for acoustics, because the people below you would hear every time you took a step.
Yeah. Yeah.
So the people on this floor would be happy. The people on the floor below would be very unhappy.
It's just like the apartment I had when I was 22.
Yeah, we all had that apartment.
Hold on a second. Do I have another question over here, or? Okay, I'll come to you in a minute.
Along the vein of what we were just talking about waterproofing and susceptibility to moisture, it seems like it'd be an ideal product for replacing concrete foundation and footings. If you could deal with the moisture issue, it would be much more environmentally friendly.
I know in Europe they are working on CLT foundations. So you're on the right track. You now know as much about it as I do.
You want to touch that?
No. Actually, when I first was setting up this session, I wanted to also talk about alternatives to concrete, because that's more of a problem than steel, I think, because the mere creation of concrete, above and beyond the energy needed to do it, releases huge amounts of CO2. But I couldn't find anybody in New Hampshire that could be a panelist and talk about it. So
I wanted to sort of pursue something, David, that you touched on, and to kind of bring this down to a more immediate relevance here in Greater Concord. As you pointed out, Concord adopted a very bold and audacious energy vision for the city, and to get there, you have to start thinking this way yesterday. Otherwise, it's not worth the paper it's written on. And Dupre's hotel out at exit 13 could have been CLT if the city had sort of started to push someone like Steve, who's a fairly progressive thinker, but he didn't. He went with the cheapest construction, and we get, as someone referred to, another Dupre soulless hotel. Now we have two huge commercial developments coming to Concord, one at exit 17, and the other one down by the Garbrands Falls Dam on the south side of Manchester Street, which is even bigger. And this is Concord's opportunity to lead. And I just hope that the city seizes the opportunity and uses this as a way to give life to this vision that they've adopted. That's more of a comment than a...
So regulars know that my motto here is, because we don't have presentations, we just have a conversation. Our motto is no politics, no PowerPoint. And that was sort of politics, but I think that was a good politics. And those of you who live in Concord and know the phone number of your city councilor, and if you get worked up about this, anyway.
Why is there politics?
That's policy.
Policy.
Yeah. I was going to say that anyways from up here, so thank you, sir, whoever you might be.
So I thought of this question before I knew that. But two quick things. One, I mean, if we can tie this into property taxes for a tax break for people who are using this kind of material, then that might be one way to get people to do this. Another question, though, is, are you getting pushback from the steel lobby?
They actually have a price on my head.
Yeah.
No. So seriously, at the national level, certainly the steel and concrete industry has pushed back hard, will continue to push back hard. Like any industry, they want to protect market share. Like any industry, we want to build market share. I think for all the reasons we've discussed, economic development, local forest management, sequestering carbon, we'll probably come up with a dozen more. This makes all the sense in the world. But yes, there is enormous pushback from competing industries.
That's the way capitalism works.
I will just say that, I was worried about this when we published the New York Times op-ed where we laid out how this could help with climate change, which was in October. And I only got one message from anyone in the concrete industry, and that was from the head of the Canadian concrete industry. And he was so nice and so polite. He was so Canadian. Basically, his comment was actually one that I agree with, which he said that life cycle assessment, so when you're thinking about the carbon impact and the impact on the atmosphere, you typically do a life cycle assessment of different materials. And he was arguing that the life cycle assessments that have been done for cross-laminated timber by the forest products industry do not pay sufficient attention to the changes in carbon that are stored in living trees. In other words, when you harvest a tree, you reduce the carbon in the forest for a period of time until the other trees grow back. That doesn't typically get accounted for in the life cycle assessments that have been done by the forest products sector. So I agree with that. In fact, New England Forestry Foundation is doing a life cycle assessment in partnership with CORIM, which is a industry research group, forest industry research group, where we're going to address that explicitly and address how does the life cycle impact change with both traditional forest management and sort of high-quality forest management. And we're expecting that with traditional forest management, the gap between concrete and wood construction will be less, although... TIMO. Yeah, TIMO's in northern Maine. For those of you who don't know, timber investment management organizations have bought most of northern Maine over the last 20 years, and they're not doing, in my judgment, they are not doing a great job of managing the forest. So.
And just to complicate it further, I know at Harvard Forest, they're doing some research about carbon released from the soil during harvesting, which is frequently not taken into account, unfortunately. So
yes, and you were right on both counts because Hubbard Brook also has a study.
Oh, Hubbard Brook. Okay, that does. Okay, those two. Just go.
So I don't want to stray into politics again, but was it difficult? This is a bit out of the box as far as building permits go. How was Newington to get this permit?
So when we started this project, we actually came up to Concord to talk to the fire marshal about this, and they were very excited about this project. They also told us that they were, right on the cusp of getting IBC 2015 passed. So they knew that it was going to happen. They knew that building was going to align with it, and so they said that we could do this, and they were okay with it. Other than that, there wasn't any additional permitting or any kind of issues like that. We basically used 2015 all in. We used the code for everything right up front, knowing that it was going to come online in September.
Those of you who've been coming to Science Cafe for a while might remember last year, a year before, we did a session on building and energy, and all the panelists there were lamenting the fact that New Hampshire was still at the time on 2009 building codes, and so they didn't seem to make it seem like it'd be likely that we would upgrade it. So.
Congratulations on getting to 2015.
Yeah, congratulations to getting to 4 years ago. Marching boldly into 4 years ago.
To promote CLT, are you working with any of the colleges in the area, the architectural programs, or the architectural firms that are located within the New Hampshire or New England area?
So I'll start that. And there, at the colleges, there's actually two spots where a lot of mass timber, CLT and other work is going on. One is at the sort of building the product itself stage. UMass, is mentioned, is doing some work on hemlock. University of Vermont's doing a little bit. Really, the big dog in this region is the University of Maine with their Composite Center, which is a world-class research institution that's doing a bunch of work on how to make this better, including use of low-grade by replacing some of these with oriented strand lumber, which is made near Holton, Maine. So
And laminated near
in LVL. So some opportunities there for some of the interior, particularly the lateral. So the ones going left-right as opposed to up-down. So there's work going on there on the how do we do the wood engineering. Then your question was around architecture, and RISD, Yale, UMass, and a few others who, again, I'm not an architect, you can probably, but there's a loose collaboration of the schools that have architecture or something like architecture that are sharing knowledge, doing some joint symposia, in effect, making sure that students coming out have some exposure. I don't think there's a big push to have CLT as the material, but when a client walks in and talks about CLT, there's some familiarity.
What about AIA or some of the professional associations?
Yeah, American Institute of Architects is doing some stuff. There is funded by the Softwood Lumber Board, which none of you have ever heard of, but it's a checkoff program similar to the Got Milk people with the softwood lumber. They've got a entire program, Woodworks, is it? Yeah. So they have a program called Woodworks that is out sort of traveling the country, doing continuing education for architects on how to become, how to develop some familiarity with this. So there's all sorts of, at all different scales, efforts around that.
I'll just add that
do some stuff.
Yeah, we do some stuff. We specifically, just this past month, we started to roll out our Forest to Cities Climate Challenge. And what we're trying to do is to create an integrated carbon value chain stretching from the investors, through the developers, through the architects and engineers, through the product manufacturers, all the way back to the forest landowners, of people who are committed to producing sustainable materials and seeing them used in wood buildings here in New England. And we've got a number of architects who have expressed interest in that. We're very much in the pilot stage of that, but look for our Forest to Cities Climate Challenge and the pledge coming online on our website soon at newenglandforestry.org. And if any of you are forest landowners or foresters or forest products manufacturers or architects or builders, you too can take the Forest to Cities Climate Challenge pledge.
We're getting near the end here. I want to free up our panelists so they can go back into traffic. Any other questions? Well, aside from you. No, it's good.
CLT seems like it really addresses structural materials compared to steel. I think that's, what you've presented here. There may be another opportunity, and I don't know if you've looked into it or heard about it, but what about combining recycled plastics, for instance, as part of the composition within here? In other words, rather than a pure wood, kill two birds with one stone. We have a recycling problem, huge recycling problem, using recycled materials in interior layers, for instance, as a hybrid. There could be acoustic, thermodynamic benefits to having more of an air gap, something less dense inside, all kinds of possibilities. I don't know if anybody's thought about that.
Yeah, so at the University of Maine's Composite Center, they are looking at all sorts of things, including some, I don't know that it's recycled plastic, but some recycled material that is, they've shown me in a video and made me sign an NDA so I don't ever repeat this. But but I can't because I'm not an engineer. I actually don't know what they told me.
Security through obscurity, it always works.
The best kind of
Right, exactly. So, but effectively they have a way to line up the fibers. Just like in an oriented strand board, which you can go to Home Depot and buy, they've lined the strands this way, then this way, then this way, then this way, or here. They found a way to align the fibers and are looking at ways to do interior pieces. All that said, insulation inside of this, recycled plastic inside of this, hemlock inside of this, red maple inside of this is a non-immediate use case. And the first thing we need is someone in New England making this, which we know how to make, and doesn't have any question marks around it. Step one. Steps 2 through 18 are very interesting. Step 1.
I'll just add that I don't think we're going to have a recycled plastic problem for long. India has done an experiment with using recycled plastic in place of pavement on its roads. And they did it in northern India, which does have weather that approaches some of the extremes here in New Hampshire. And after 3 years, they have 0 potholes, 0 cracking, 0 wear problems, and the country is going to making recycled plastic, the preferred paving material on all state products, federal, all government projects.
And just to be clear, when you say extremes in here, northern India is southern Himalayas, which are known to, they're roughly the size of the White Mountains, so.
All right, and I saw an article today about making bricks out of biosolids from your wastewater treatment plant, so poop bricks. So, that would be another recycling. So, all right. Okay. I think that is it. So if you would join me in thanking our panelists. And thank you all for showing up. Once again, sciencecafenh.org to keep track of what's going on. If you haven't signed up already, there will not be one in December, but there will be one in January, and I'll be sending out emails and writing about in the Monitor and on granitegeek.org. And that's it. Thanks.